Hello, Mark here with you again to talk about sets of numbers. Okay, we're going to look at natural numbers, whole numbers, integers, rational numbers, and irrational numbers, all the numbers that make up sets of numbers. So let's begin with natural numbers. Natural numbers, they're your counting numbers. Okay, the ones you learned when you were young, the ones you learned to impress your parents when you could count 1, 2, 3, 4, 5, 6. You thought that was all the numbers that existed in the world. Okay? And then you got a little bit older, right? And you found out about this concept of zero. Okay? Now that's the only difference between natural numbers and whole numbers. 0, 1, 2, 3, 4. Okay? So the only difference between natural numbers and whole numbers is the addition of one single number, and that number is 0. Now 0 is a big deal. Right? 0 actually wasn't used in Europe until about the 1200s, although it was actually discovered back in the 600s. If you're ever curious, you could search up the history of 0. It's actually rather interesting. Well, to us math people it is anyway. But that makes a whole difference. It's a whole different concept. So you have whole numbers. The next set of numbers are integers. Now integers are your negatives and 0 and your positive numbers. One thing you'll notice is there are no decimals and there are no fractions. Okay? So natural numbers are just your counting numbers. Whole numbers are your counting numbers, 1, 2, 3, 4, 5, plus the 0. Integers are your positives, the 0, and your negative numbers, okay? But there are no decimals or fractions, okay? The next thing we get into are rational numbers, which has the decimal and fractions. We're going to look at a more visual representation of how those work. So it's kind of ever expanding. So let's start with the natural numbers. Okay? And that's that group of numbers there. And we just looked at what they were. And then we added a number. We added 0. So we have the whole numbers. Now there's only one more number in the whole numbers, but it creates a bigger set. And then we added integers. Okay? Now there are a lot more integers, right? Because they're all the negatives. So you'll notice all the naturals are also whole numbers. All the whole numbers fit inside the integer of circle of integers. They're also integers. And then outside of that, we have what we call rational. Okay? And we'll look at it here. And all the integers are also rational numbers, but rational numbers include your decimals and your fractions. Okay? So rational numbers include fractions and decimals. Okay? So anything that can be written as a fraction is a rational number. And you might say, hold on, well, why are all the integers rational numbers? Because if I took, we'll do it right here. If I took the number 17, that's not a fraction or a decimal. But it's all the numbers that can be written as fractions. Can I write 17 as a fraction? Yes, I can. 17 over 1. Okay? It's a little bit of a cheap way to do it, but you can write 17 as a fraction, 17 over 1. So anything that can be written as a fraction, okay, and almost all decimals, because almost all decimals in a sense could be written as a fraction, are called rational numbers. The other set of numbers are irrational. Now they're not bigger, they're over here. Okay? They're their own set. Irrational. Okay? Now, you might say, hold on, what are these? Okay? Okay? Because a number is either rational or it's irrational. It cannot be both. All the natural numbers, whole numbers, and the integers are all rational numbers, as well as all the fractions and a lot of the decimals. Okay? But what's an irrational number? An irrational number is a non-terminating and non-repeating decimal. Okay. Remember I said a lot of the decimals are rational numbers? Only the ones that can be, they're decimals that can, that can be written as a fraction. Okay. So there are decimals that cannot. Decimals that are non-terminating, which means they go on forever, they do not end, and are also non-repeating, so they don't have a pattern, are irrational. Right? So a famous example of an irrational number is pi. Okay? Pi is, you always learned it as 3.14 when you were younger, but if you put it into your calculator, you'll see it's 3.1415926535, and then it continues. I don't remember it any farther than that, but it goes on forever, right? And it will not repeat. Okay? There's no pattern that repeats over and over again. What else are irrational numbers? Anything that's a square root that does not make a perfect square. So the square root of 7 would be irrational. Okay? It does not make a perfect square. What makes a perfect square? Well, the square root of 9 is 3, because 3 times 3 is 9. So it would not be irrational, because the square root of 9 is 3, which is actually just a natural number. So any square root that is not a perfect square, like the square root of 9, or the square root of 16, or the square root of 25, any that are not those are all irrational numbers. So it ends up being a lot of them, because any number that you have that you can take a square root with, almost any number will be irrational. Okay? So you have your natural numbers, which are your counting numbers, your whole numbers, which includes 0, your integers, which are all your positive and negative numbers, but no fractions or decimal. Then your rational numbers, which are fractions or decimals that can be written as fractions. And if a number is not that, then it must be irrational. Okay? Famous example is pi. Okay? Other good examples are the square root of most numbers are also irrational. Irrationals must be non-terminating and non-repeating decimals. Okay? I hope that makes sense. Look through slides 44, I think, to 56, the next group of slides, and I'll have this video posted at the end of this topic as well. Have a great day.